Um, so this is actually this object that we see on the screen, which is from question number 4, is actually called the 4-bar linkage. Let me just spend sort of 5 minutes on the topic. So it's called a 4-bar linkage. And it's called a 4-bar linkage because it's got 3 bars, unfortunately. So bar 1, bar 2, bar 3. And it's actually called a 4-bar linkage because they treat the ground to which this is attached as another 4th bar as well. So that's why it's actually called a 4-bar linkage. It's not a joke necessarily. So yeah. So it's, but usually, I guess when it's connected to the ground, it's actually got 3 bars. But yeah, so imagine you have these 3 things that I'm drawing on the pad. So we have A, B, C, D, and let me not necessarily do like all the numbers and so on, but basically we are given, let's say omega AB, and we are given alpha AB. So omega AB, alpha AB given, and and then also given are given positions of A, B, C, D. Okay, so we know the positions of all those points, so we can compute things like R A with respect to B or whatever, right? So R B with respect to A if you want.
Professor?
Or yeah.
Could you move your PDF off the screen? Because
Oh
it's just
yes,
covering
thank you. Yeah, cool. Sorry about that. Yeah.
Thank you.
Thanks. Thanks for letting me know. I guess a couple of folks are set that on the chat window as well. Okay, cool. Yeah, so we can compute these things because the position is given. The positions of all those points are given. So R C with respect to B or R D with respect to C, right? So the positions of all those points are given. So these are just vectors from one point to another point. And then you're like in this particular problem, you're asked, so let's say e.g. Q4 on homework 7. So you're asked, I think, let's say things like, I think in part A, you're asked things like omega BC, maybe omega CD, maybe one or both of them. And then in part B, you're asked, let's say alpha BC, alpha CD. If you find these things, you can also find like the velocity of this point, the velocity of this point, and so on. In general, if you find the angular velocities of these 2 things and angular accelerations of these 2 things, everything else you can sort of find after that, relatively straightforward. Okay. So for part A, so all these problems more or less follow the same template. Okay. So there's just 2 equations, one for velocity, one for acceleration, and you just keep using them over and over again until you have enough equations and the unknowns. So for part A, just do, so like VB equals VA plus omega AB K crossed with R B with respect to A. So that's equation number 1. This is known, this is known, this is known. So you can compute this, VB. And then VC equals VB plus omega BC K cross R C with respect to B. This is 2. This is known now. So once you've executed equation number 1, you will know VB. And then this is not known, this is known, and this is not known, okay? And then you do VC, like between these two things, and then you go let's say D equals VC plus omega CD K cross to it, crossed with our D with respect to C. This is just a position vector, it's known. This is not known. This thing is not known. And this thing, what is VD? So that's just the velocity of point D, which is going to be 0, right? So point A is 0, point B is 0. So this happens to be 0. This is basically known. This is 0, okay? So this is equation number 3. So plug in equation number 1 into equation number 2, equation number 2 into equation number 3 for VC. And basically you have this equation, VD equals VC, which is, so let me just say, plug in 1 in 2 and 2 in 3. So basically we'll have VD equals VC, which is VB plus omega BC K cross RC with respect to B plus omega CD K cross RD with respect to C. And then VB itself is this whole thing. So you can plug that in there from, let's say, 1, and then remove, this is basically 0 because VD is 0, okay? So basically this equation, let's call this equation number 4, has two unknowns, two scalar unknowns. Namely omega BC and omega CD. And then this is one vector equation. One vector equation is two scalar unknowns, okay? Because you have a I equation, and then we have a J equation. Basically use these two things to solve for omega BC and omega CD, okay? So that's how that proceeds. Any questions about this? Looks like there's a couple of things in the chat window. Okay, yeah, so Sean says it only says we need to find the angular velocity of an acceleration of bar BC. Cool. But it turns out that unfortunately, finding this is basically the same as finding this. They sort of, you have to solve them simultaneously, basically. You'll have two equations and two unknowns. In the two unknowns, and then you can solve for whichever one they ask you, I guess. But yeah, you don't have to solve for both, but you will get, the procedure is the same, whether they ask you both or one or the other. So that's for part A. And then part B, you do exactly the same thing. Exactly same. Except you do this equation, AB or whatever. B with respect to A. Let's call this equation, I don't know, 5 or something. And then we do a C equals AB plus alpha BC K cross R C with respect to B minus omega BC square R C with respect to B. And then AD, AA is 0, AD is 0, which is AC plus alpha CD. So basically, this is given, this is known, this is known, this is known. So basically, AB is known, and then plug in 5 and 6, and plug 5 and 6, then 6 and 7. Everything known except alpha BC and alpha CD, the scalars, two scalars. And basically what you will get when you do this is one vector equation, which is two scalar equations. So I equation, and then the J equation, and then you solve. So that's the procedure. Part B is basically the same as part A, except, well, unfortunately, there's a couple of more terms in there, and then you will have to use the answers from part A in part B, because you have these terms, omega BC, omega CD, and so on. Any questions? So for all these problems, really, you can sort of really safely bet that there is no more mystery than basically using these equations over and over again. You find 2 points on the rigid body, write an equation that relates, say, velocities or accelerations, and sort of do that for all the salient points in the problem. And you will find that you have enough equations and unknowns. So this whole homework, in some sense, is that, I guess, except for one weird problem. Any questions? I guess there's a chat window question. Yes, I will post this notes in a minute. Yeah. The rest of the notes for today's lecture, I sort of already posted, but this one I will post like the next 5 minutes or whatever, end of today's lecture, or sometime in the next few minutes. Yeah. Cool. Any other questions? Okay.